whatever, it's some function. I tried this a couple weeks ago, but I'm going to try it again now. Take 15 seconds to think about it. Based on the portion of the graph I have shown you, at how many points on the graph are you 100% sure you know the value of the derivative? Take a second to think about it. I'm thinking 3. There are 3 points on this graph where I am 100% sure I know what the value of the derivative is. Because the only places that I'm completely sure about it are places where the slope of the tangent line is flat. So my derivative is for sure equal to 0. And I'm just going to write that in as m equals 0 because I just think we're all trained to think of the slope as m. Maybe that's just me. I don't know. So now we get into what a former colleague of mine calls roller coasterology. Does anyone like roller coasters? I do not. I find them nauseating. But let us imagine that we're at a theme park and I don't know. Okay. It's probably not a really exciting roller coaster here. We're like at some old school theme park. Just one of those really extra weird ones where everything's made out of wood. You feel like the whole thing would break at any moment. Okay. So if I imagine that I am riding on that roller coaster as I go from left to right, right now, we're going up and up and up and up and up and up and up. And then we hit this point and then we go. Whoosh. By the way, this roller coaster wouldn't really work in this direction very well. Now that I'm thinking about gravity here, I haven't recovered enough momentum. Anyway, we won't get hung up on the physics of it. We're going up and then we're going down and then we're going up again and then we're going down. Well, in this entire chunk where I'm going up, that means that my values of y are increasing because we're going up. I don't know why I've started writing a C over there. My y is increasing. By the way, in that chunk where y is increasing, if I think about what the slopes of these tangent lines are, they're all what kind of values? Totally. Which means that everywhere in here, my y prime would be greater than 0. Now, when I look in the next chunk, right, we're going down, 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 down until here. So everywhere in this part of it, if I think about what those slopes look like the slopes are changing, but they're all negative. So everywhere in here, my y primes are less than 0. Here, I'm going up again. And if I'm going up, I know that all of those slopes are going to be positive. And over here, I'm coming down, and I know that all of those slopes are going to be negative. So if I give you the picture, my guess is that you all have a pretty good sense of roller coasterology, and you could determine where things are positive and negative, right? Just from this, from the picture. But what if I take the picture away and I just give us some gross function? We want to be able to accomplish the same thing. So let's see if I can kill 2 birds with 1 stone. Did you have a gross function that we can take a derivative of?
12
It may or may
It was
not
this
work.
one. I don't think so.
It's not gonna work. Okay, okay. I thought I was gonna manage to do two things at once. I'm gonna make up a gross function. Scale of 1 to 10, 10 being terrible. Where do you want it to be? A 7? 7 or an 8? Okay, you got it. Y is going to be. We got this. We got this. Okay. X minus 3 to the 4th power times x plus 1 to the 3rd. I'm going to give you all 2 minutes to take that derivative. Are you going to need a product rule? Yes, you are. Are you going to need a chain rule? Why, yes, you are. I'm going to let you take 2 minutes to get as far as you can in that derivative on your own. And then we'll work on it together. And don't worry about trying to simplify it. We'll simplify it together. Just wanted to get a derivative. Maybe we don't need 2 minutes. I don't know. I don't even. I feel like I made this a 7 as an overall problem, but it's not a 7 in terms of just the straight derivative. I could have made the chain rule part kind of come up more. I didn't. I'm dumping it. Okay. Oh no, I'm just saying I most people have something on their paper, so I don't think we need the full 2 minutes. Okay, so let's go ahead and derivatize. When I take the derivative of the first piece, I've got garbage to the 4th. So I'm going to have 4 times that stuff cubed times, chain rule says that I should derive the inside, but the derivative of x is 1 and the derivative of 3 is 0. So I don't have to write that piece. I should have made something where I did. Sorry. I leave the second piece alone. Now I leave the first piece alone. Take the derivative of the second piece. So I've got a 3 and the x plus 1 squared. Same thing happens. I should multiply by the derivative of the inside, but the derivative of x is 1 and the derivative of 1 is 0. So I quit. Here's where the fun comes in. I didn't actually ask us a question, so I probably should ask a question. And my question is going to be, on what intervals is y increasing? There are other questions that I could ask, but we'll start with this one. Now, I'm going to go back to my roller coasterology analogy for a second. The places where we switch from increasing to decreasing are those places where my derivative hits a flat spot, or rather where my function hits a flat spot because the derivative is 0. So if I want to know whether we're increasing or decreasing, really the first thing I have to figure out is where is that whole thing equal to 0? Once upon a time, when you took probably algebra 2, you encountered factoring by grouping. Honestly, the whole reason you did that was leading up to this moment right here. Factoring a product rule. I've got a plus, which is separating these two pieces. So I got 2 groups, and now I'm going to factor out whatever they have in common. Let's see, they both have some x plus 1s. In fact, they both have an x plus 1 squared. And they both have some x minus 3s. Yep, they both have an x minus 3 to the third. And when I pull all of that stuff out of my first part, I'm left with a 4 and an extra x plus 1. And when I factor all of it out of the second piece, I'm left with a 3 and the extra x minus 3. Visually, it's a little hard for me to deal with it all separated out like that. So I'm going to collect this together to say x minus 3 cubed, x plus 1 squared. And then all of this stuff in parentheses, I'm going to combine together. So I'm going to distribute the 4 and distribute the 3. So I'll end up with a 4x plus a 3x. And then I'll end up with a 4 minus 9. Two options for where we go from here. I'm going to show you my favorite. And if you really hate it, we can do it a different way. Well, okay, figuring out where this is positive, that part of it is pretty straightforward. I've got 3 things multiplied together and it equals 0. So one of those 3 things is 0. So either x is 3 or a -1 or 5/7. But what we actually cared about is where are we going up on the graph? So I'm not going to graph the whole thing, but I am going to imagine for myself what that x-axis looks like. I know that these are the places where my derivative is 0. So from left to right, I'm looking at -1, 5/7, and 3. And I need to know in each of these regions what is happening with my derivative. So I'm just going to remind myself that this was my f prime function because I care about what's happening with the derivative. Once upon a time, you probably also solved inequalities. Some people make charts. Some people use test points. Some people use their algebra skills. I'm going to go test points today, and by Tuesday, I'm going to use some algebra skills. Today, I'm going to say, I've divided our graph up just like we divided the graph up here between the places where the slopes are 0. And in each of those regions, I need to find out if the derivative is positive or negative. So I'm going to pick some test points since we don't have a graph. So in here, my test point, I'm going to choose a 0. How about a good number between 5/7 and 3? 2 will work. Something bigger than 3, like 4, and something less than -1, I'll choose -10. You can choose whatever you want, and that's really the point that I was trying to make. But here's the cool thing. I don't actually care what the value of the derivative is. I only care if it's positive or negative. So I'm not going to get hung up on computing numbers. So when I plug in 0 to the derivative, 0 minus 3 is negative. And when I cube it, it's still negative. When I plug in 0 here, 0 plus 1 is positive, and when I square it, it's still positive. When I plug in 0 here, I just have -5, which means it's negative. And a negative times a positive times a negative means overall we're positive. And if my derivative is positive, it means my graph was going up. If I plug in 2 minus 3 is a negative number. And if I cube it, it's still negative. 2 plus 1 is a positive number. If I square it, it's still positive. When I plug in 2 over here, I've got 17 minus 5, whatever, is positive. A negative times a positive times a positive, that's going to make that negative. Whole thing coming down. If I plug in 4 minus 3 is positive, and if I cube it, it's still positive. 4 plus 1 is positive, and if I squared it, it's still positive. 7 times 4 is 28 minus 5, we're still positive. Again, don't get hung up on the numbers. Negative 10 minus negative 3 is negative, and if I cube it, it's negative. Negative 10 plus 1 is negative, but when you square it, it turns positive. 7 times negative 70 minus 5, that's another negative. A negative times a positive times a negative overall is positive. So if I think about this in terms of roller coasterology, I was going up and then I kept going up. And then I was coming down and then I was going up again. In terms of the intervals where we're increasing, I'm looking at negative infinity to negative 1. Punch a hole out at negative 1 because at negative 1, technically we're not increasing, the slope is 0. At 5/7, the slope is 0, but I'm going to skip this entire chunk between 5/7 and 3 because I specifically asked for increasing. Now, the nice thing is that our textbook, every time it asks this question, asks for open intervals. So it's always clear we should not include the numbers. We're always open intervals. Question?
So you make it
yeah. At negative 1, the derivative is equal to 0, but increasing would mean the derivative is strictly positive. It's something bigger than 0, not with the or equal to. And our book just kind of skirts the whole thing by always asking for open intervals, meaning we should never include the point.